All right, welcome back to another video. We're going to continue to go through the Python for DevOps book. Fortunately, really disappointing chapter 7. I really glossed over a lot of the examples because I couldn't get them to work. Lots of typos in it too, real simple grammatical errors and errors in the code examples. Big disappointment, but the good news is that I guess it went over logging, so I guess it did go over something that would be like really intensely relevant to me, logging, but it's kind of not the main thing I'm interested in the book. So chapter 8 is about PiTest for DevOps, so let's dive into it. Continuous integration, continuous delivery, deployments, and any pipeline workflow in general with some thought put into it will be filled with validation. This validation can happen at every step of the way and when achieving important objectives. For example, if in the middle of a long list of steps to produce a deployment, a curl command is called to get an all-important file. Do you think the build should continue if it fails? Probably not. Curl has a flag that can be used to produce a non-zero exit status, -- fail, if an HTTP error happens. That simple flag usage is a form of validation. Ensure that the request succeeded, otherwise fail the build step. The key word is to ensure that something succeeded, and that is at the core of this chapter. Validation and testing strategies that can help you build better infrastructure. Thinking about validation becomes all the more satisfying when Python gets in the mix. Harnessing testing frameworks like PiTest to handle the verification of systems. This chapter reviews some of the basics associated with testing in Python using the phenomenal PiTest framework, and then dives into some advanced features of the framework, and finally goes into detail about the Test Infra project, a plugin to PiTest that can do system verification. Testing superpowers with PiTest. We can't say enough good things about the PiTest framework. Created by Holger Kriekel, it is now maintained by quite a few people that do an incredible job at producing a high-quality piece of software that is usually part of our everyday work. As a full-featured framework, it is tough to narrow down the scope enough to provide a useful introduction without repeating the project's complete documentation. Tip: the PiTest project has lots of information, examples, and feature details in its documentation that are worth reviewing. There are always new things to learn as the project continues to provide new releases and different ways to improve testing. When Alfredo was first introduced to the framework, he was struggling to write tests and found it cumbersome to adhere to Python's built-in way of testing with unit test. This chapter goes through the differences later. It took him a couple of minutes to get hooked into PyTest's magical reporting. It wasn't forcing him to move away from how he had written his tests, and it worked right out of the box with no modifications. This flexibility shows throughout the project, and even when things might not be possible today, you can extend its functionality via plugins or its configurations files. By understanding how to write more straightforward test cases, and by taking advantage of the command line tool, reporting engine, plugin extensibility, and framework utilities, you will want to write more tests that will undoubtedly be better all around. Getting started with PyTest. In its simplest form, PyTest is a command line tool that discovers Python tests and executes them. It doesn't force a user to understand its internals, which makes it easy to get started with. This section demonstrates some of the most basic features, from writing tests to laying out files, so that they get automatically discovered. And finally, looking at the main differences between it and Python's built-in testing framework, unit test. Tip: most integrated development environments, IDEs, such as PyCharm and Visual Studio Code, have built-in support for running PyTest. If using a text editor like Vim, there is support via the PyTest.vim plugin. Using PyTest from the editor saves time and makes debugging failures easier. But be aware that not every option or plugin is supported. Testing with PyTest. Make sure that you have PyTest installed and available in the command line. Okay, so I've got my lab here, so we'll start up this. Might need to install Python again, unfortunately. I'll find out in a moment here once the console line opens up. Okay, so here's the console, or here's the terminal. All right. I found something kind of cool too that you can do. So my server is at a particular IP and a particular port. It's at 192.168.1.8, which is a IP in my local area network, so it's not on the public internet. And it's open on port 3080, but I can go actually to that address in GNS, or sorry, in a browser, and it takes me to a different way to access my lab. So I just didn't know that GNS provided such shareability. I had always considered, oh, I forget what it's called, but there's Eve NG. I had always considered that the more shareable program to use. But if I can just use it like this, and then have a web console and a new tab like this, this is almost more shareable than GNS. So yeah, let's do it this way. Instead of having this window up, we're going to close that, and then we're going to do the example in another tab here. Oh, actually, you know what? Okay, yeah, let's do it like this. Okay, so we got to see if Python 3 is installed. It is not installed. Okay, so let's do apt-get update. Yeah, this is a much better terminal too. Like the shell that is not in the browser is just a lot worse. Oh my god. It is 7:53. Alright, it seems to be going a lot slower than usual. I don't know if that's because I'm accessing it over the browser or what the deal is. Maybe my internet's just slower than usual. Looks like we're going at 192 kilobytes per second. That is pretty slow. That's definitely very slow. That's really slow. I should be able to pull more than that. Yeah, I think it's just my internet's like super slow right now. Let's see if I can read ahead while this is going. So create a file called test_basic.py. It should look like this. Okay, we'll do that once we can do that. If PyTest runs without any arguments, it should show a pass and a failure. Okay. Can move ahead the bookmark. The output is beneficial from the start. It displays how many tests were collected, how many passed, and which one failed, including its line number. Tip: the default output from PyTest is handy, but it might be too verbose. You can control the amount of output with configuration, reducing it with the -q flag. There was no need to create a class to include the tests. Functions were discovered and ran correctly. A test suite can have a mix of both, and the framework works fine in such an environment. Oh my god, everything is... Okay, here we go. Oh, god damn it, okay. Alright, there we go. Oh, it's gonna be slow again. Yeah, it's still slow. I'm kind of curious to try it in the not in the browser and see if it goes faster. But I don't know why that would make a difference. I mean, it's just the like the actual traffic isn't different in any way. Like it's just displaying it to the screen. It's not actually causing it to go slower. Like the thing that is going slower is not dependent on whether it's accessed in a browser or through a PuTTY terminal. Okay, so we'll do, I forget what the command is, so I'm just gonna have it fail. There you go, and it's apt get installed Python 3 VNV. Okay, finally, that was awful. Oops, and now I don't have my, okay, that I have it now. Oh, it looks like it's like a few lines. Oh, I see, I've got a scroll bar there. Okay. Okay, so we gotta make a file called test.py. Basic.py. Okay. Simple. True. Test fails. Assert false. All right. Do a cancel on that. There we go. Okay, I've never seen these options before. I don't know what is going on here. I'd like to just have the regular options. Oh, so okay, so we've got this test basic, so let's copy this to Yeah. There we go, and now we can remove the one with the extra characters. There we go. Perfect. All right, let's give it a try. So PyTest runs without any arguments. It should show a pass and a failure. PyTest command not found. Okay, so we got to do a pip install on that. Okay, hopefully it works better now. There we go. So we did get a result, but unfortunately we got not set final. So let me try this. I'm going to do pip install upgrade pip. Okay, and then I'll try installing PyTest again. Maybe. Okay. Now it looks like pip is broken. Yeah, I have no idea. I have no idea what's going on. And I don't like this. I don't like the browser because I've got to scroll up and down. So I'm going to go back to the console here. This like SolarWinds putty. I'm going to use that instead. And now it should work exactly the same. Yeah, I should get the same output because it doesn't depend on this at all. But unfortunately, it is not being fun. Okay, so that didn't work. Let's just keep on going. Didn't work. I don't know why, but there's no time to waste. Okay, so the next part is layouts and conventions. When testing in Python, there are a few conventions that PyTest follows implicitly. Most of these conventions are about naming and structure. For example, try renaming the test basic.py file to basic.py and run PyTest to see what happens. So for me, PyTest doesn't work for some reason. So we're going to skip this. It looks like it doesn't run any tests when you do that. No test ran because of the convention of prefixing test files with the test oops, and I lost my place here. Okay, underscore. If you rename the file back to test underscore basic.py, it should be automatically discovered and tests should run. Note, layouts and conventions are helpful for automatic test discovery. It is possible to configure the framework to use other naming conventions or to directly test a file that has a unique name. However, it is useful to follow through with basic expectations to avoid confusion when tests don't run. These are conventions that will allow the tool to discover tests. The testing directory needs to be renamed tests. Test files need to be prefixed with test, for example, test underscore basic.py or suffixed with test.py. Test functions need to be prefixed with test underscore, for example, def test simple. Test classes need to be prefixed with test, for example, class test simple. Test methods follow the same conventions as functions, prefixed with test underscore. For example, def test underscore method self. Because prefixing with test underscore is a requirement for automatic discovery and execution of tests, it allows introducing helper functions and other non-test code with different names so that they get excluded automatically. All right, so you know what? I'm kind of running out of energy on this, but let's set a goal here. I'm going to get to PyTest features. So we'll plow through until PyTest features, and then Unfortunately, it's going to be a shorter video. Differences with unit test. Python already comes with a set of utilities and helpers for testing, and they are part of the unit test module. It is useful to understand how PyTest is different and why it is highly recommended. The unit test module forces the use of classes and class inheritance. For an experienced developer who understands object-oriented programming and class inheritance, this shouldn't be a problem, but for beginners, it is an obstacle. Using classes and inheritance shouldn't be a prerequisite for writing basic tests. Part of forcing users to inherit from unittest.testCase is that you are required to understand and remember most of the assertion methods that are used to verify results. With PyTest, there is a single assertion helper that can do it all, assert. There are a few of the these are a few of the assert methods that can be used when writing tests with unit test. Some of them are easy to grasp, while others are very confusing. So here's the assertion methods. I'm not going to read them all. Let's just keep on going. PyTest allows you to use assert exclusively and does not force you to use any of the above. Moreover, it does allow you to write tests using unit test, and it even executes them. We strongly advise against doing that and suggest you concentrate on just using plain asserts. Not only is it easier to use plain asserts, but PyTest also provides a rich comparison engine on failures. More on this in the next section. Okay, so I think I can go longer, but I need to take a quick break. I'll be right back. Okay, I'm back. I can go a bit further than I thought I could. PyTest features. Aside from making it easier to write tests and execute them, the framework provides lots of extensible options, such as hooks. Hooks allow you to interact with the framework internals at different points in the runtime. If you want to alter the collection of tests, for example, a hook for the collection engine can be added. Another useful example is if you want to implement a nicer report when a test fails. While configuring an HTTP API, we found that sometimes the failures in the tests that used HTTP requests against the application weren't beneficial. An assertion failure would be reported because the expected response at HTTP 200 was an HTTP 500 error. We wanted to know more about the request, to what URL endpoint. If it was a post request, did it have data? What did it look like? These are things that were already available in the HTTP response object. So we wrote a hook to poke inside this object and include all these items as part of the failure report. Hooks are an advanced feature of PyTest that you might not need at all, but it is useful to understand that the framework can be flexible enough to accommodate different requirements. The next sections cover how to extend the framework, why using assert is so valuable, how to parameterize tests to reduce repetition, how to make helpers with fixtures, and how to use the built-in ones. Conftestpy. Most software lets you extend functionality via plugins. Web browsers call them extensions, for example. Similarly, PyTest has a rich API for developing plugins. The complete API is not covered here, but its simpler approach is the conftestpy file. In this file, the tool can be extended just like a plugin can. There is no need to fully understand how to create a separate plugin, package it, and install it. If a conftest.py file is present, the framework will load it and consume any specific directives in it. It all happens automatically. Usually you will find that a conftestpy file is used to hold hooks, fixtures, and helpers for those fixtures. Those fixtures can then be used within tests if declared as arguments. That process is described later in the fixture section. It makes sense to add fixtures and helpers to this file when more than one test module will use it. If there is only a single test file, or if only one file is going to make use of a fixture or hook, there is no need to create or use a conftestpy file. Fixtures and helpers can be defined within the same file as the test and behave the same. The only condition for loading a conftestpy file is to be present in the test directory and match the name correctly. Also, although this name is configurable, we advise against changing it and encourage you to follow the default naming conventions to avoid potential issues. The amazing assert. When we have to describe how great the PiTest tooling is, we start by describing the important uses of the assert statement. Behind the scenes, the framework is inspecting objects and providing a rich comparison engine to better describe errors. This is usually met with resistance because a bare assert in Python is terrible at describing errors. Compare two long strings as an example. Okay, so we're going to assert that these strings equal each other, but it looks like they do not. This string has one less s, so we got an assertion error because it's not possible to assert that these are equal because they are in fact not equal. Where is the difference? It is hard to tell without spending time looking at those two long lines closely. Oh, well, I saw it right away. This will cause people to recommend against it. A small test shows how PiTest augments when reporting the failure. I don't see how it augments. Can you tell where the error is? This is tremendously easier. No, it's not. I can't even tell. I mean, maybe it's just because the book formatting doesn't persist, but I mean, I will say this is not, like, I don't even see where the word assert is on here with a single S. Like, it's not even there. Oh, here it is. But I mean, maybe it's because of the book formatting, but no, that was not easier. Like, I saw it right away. I mean, they're stacked on top of each other. Like, no, this does not make it easier. It makes it harder. Yeah, okay, chapter 8 is, I think, in the same category as chapter 7. I might stop reading this book. This is awful. Can you tell where the error is? This is tremendously easier, I guess, if you are, I guess if you have proper formatting of it, but I mean, I guess I could try running it and see the formatting that comes out onto the terminal, but I mean, it hasn't been working for me. Not only does it tell you it fails, but it points to exactly where the failure is. The example is a simple assert with a long string, but the framework handles other data structures like lists and dictionaries without a problem. Have you ever compared very long lists in tests? It is impossible to tell exactly what items are different. Just do a set intersection. Here is a small snippet with long lists. So yeah, so you can assert a very long list of items. You can see it's missing the of, but if you use the assertion error at index 4, if of does not equal, so left contains more items, first contains extra items. Okay, so that's pretty nice. After informing the user that the test failed, it points exactly to the index number. That's nice. Index 4 or 5th item. And finally, it says that one list has one extra item. Without this level of introspection, debugging failures would take a very long time. The bonus in reporting is that by default, it omits very long items when making comparisons, so that only the relevant portion shows in the output. After all, what you want to know is to know not only that the lists or any other data structure are different, but exactly where they are different. Okay, so that is pretty nice. That it'll point. This output here is pretty nice. Next section is parameterization. Parameterization is one of the features that can take a while to understand because it doesn't exist in the unit test module and is a feature unique to the PiTest framework. It can be clear once you find yourself writing very similar tests that had minor changes in the inputs but are testing the same thing. Take, for example, this class that is testing a function that returns true if a string is implying a truthful value. The string to bool is the function under test. Okay, so from my module, import string bool. I don't have my modules, so we'll just skim over this. I don't know. I'm questioning how I'm spending my time here, but let's just power through it. See how all these tests are evaluating the same result from similar inputs. This is where parameterization shines because it can group all these values and pass them to the test. It can effectively reduce them to a single test. Okay, I can see how that is nice. There are a couple of things happening here. First, PiTest is imported, the framework, to use the PiTest.mark.parameterize module. Then true_values is defined as a list variable of all the values to use that should evaluate the same. And finally, it replaces all the test methods to a single one. The test method uses the parameterize declarator, which defines two arguments. The first is a string value, and the second is the name of the list defined previously. This can look a bit odd, but it is telling the framework that the value is the name to use for the argument in the test method. That is where the value argument comes from. If the verbosity is increased when running, the output will show exactly what value was passed in. It almost looks like the single test got cloned into every single iteration passed in. The output includes the values used in each iteration of the single test in brackets. It is reducing the very verbose test class into a single test method thanks to parameterize. The next time you find yourself writing tests that seem very similar and that assert the same outcome with different inputs, you will know that you can make it simpler with the parameterize decorator. Alright, so next section is fixtures. Let's see what's in store, if there's an end in sight. So it looks like there's no end in sight. I'm at the 34 minutes mark on this video. Yeah, I'm kind of starting to really dislike this book. It's just not doing it for me now. Like there's too many. First of all, like with the formatting and stuff all mixed up, I'm just not really getting the key takeaways and points from a lot of this output. Second of all, the examples aren't working for me. I can't get them to work in my lab. Um, I haven't really seen any grammatical errors so far, but um, it's becoming pretty dry. There used to be a lot more like I wish the authors would talk more about um, okay, let's just keep on skimming through this because as I said, I'm becoming a bit disappointed with this book, and I was really excited by it. So I'm kind of surprised that I'm running into yeah. It just seems like a lot of this isn't as relevant to me as I thought it would be. I thought this would be really relevant to me. Okay, so I think that's going to be it for this video. We're going to keep plugging away at this, but um, for now we're going to end it on fixtures. When we come back, we'll be diving into that. You know what? Let's just read until this getting started so that it's more clear where we left off. We can think of PiTest fixtures like little helpers that can get injected into a test. Regardless of whether you are writing a single test function or a bunch of test methods, fixtures can be used in the same way. If they aren't going to be shared among other test files, it is fine to define them in the same test file. Otherwise, they can go into the conftestpy file. Fixtures, just like helper functions, can be almost anything you need for a test, from simple data structures that get pre-created to more complex ones like setting a database for a web application. These helpers can also have a defined scope. They can have specific code that cleans up for every test method, class, and module, or even allows setting them up once for the whole test session. By defining them in a test method or test function, you are effectively getting the fixture injected at runtime. If this sounds a bit confusing, it will become clear through examples in the next few sections. Okay, so that's going to be where I stop. So yeah, I'm going to make another video tonight, yeah, that's the end of this video where I read through this book. So stay tuned for the getting started section in this series. But to be honest, I might be focusing on some other of the playlists I've got going for a while. All right, thanks for watching.